So okay, right. So we continue. Right, over here. Okay, this one. Now we are talking about instantaneous acceleration. Now, instantaneous acceleration is no longer the average acceleration. Average acceleration is the acceleration taken over a period of time. Over a period of
Okay.
time. Instantaneous acceleration is the acceleration at that particular moment. At that particular moment, it is not stretched over a period of time.
Okay.
Okay, right. Okay. Instantaneous acceleration of an object at a given time equals the slope of tangent in the velocity versus time graph.
Okay.
Okay. Now, consider a car moving this way from left to right. Okay. So, at different points P and Q, they have different velocity. At P, the velocity is VI, the initial velocity. At Q, the velocity is the VF, the final velocity. Okay, right. So we look at the graph, this graph here, which is the graph of velocity. I mean, you see here. It's a graph of velocity versus time. You have to look
Okay.
at the label on the x-axis and y-axis. Okay, so if it is velocity and time, then it's velocity versus time. Sometimes it may be position versus time. Sometimes it may be acceleration versus time.
Just time.
Okay,
Okay.
now the average, let's say from P to Q, the velocity change. Okay, sometime fast, sometime increasing very at a very high rate, sometimes increasing but at a lower rate. Probably, let's say at first it's 5 meter per second square, then sometime later it is only 2 meter per second square. So the acceleration change, okay, all the time. The acceleration is changing all the time. So that's why we have this red line here. Okay, the average velocity is not the sorry, the average acceleration is not the acceleration along the red line. It is just the straight, the blue line, the straight blue line. So it's actually the delta V over the delta T. Now, if you want to talk about the instantaneous, you want to talk about the instantaneous acceleration, it is actually the instantaneous, let's say at P, the instantaneous acceleration is actually the tangent at the point T. It's actually the tangent at the point T. Okay, it's actually the tangent at point T. If you want to talk about the instantaneous acceleration here, somewhere maybe it's called R, then it is the slope of the tangent at this point R here. Okay, it's the slope at this point here. So the instantaneous acceleration is actually the slope at that point, the slope of the tangent at that point. However, if you take a blue line, the straight blue line like that, then it will represent the average acceleration. Okay, right. So now we have three graphs on the right here. We have three graphs.
Okay.
All of them are labeled velocity versus time, velocity versus time, velocity versus time. Okay, so three of them, they are velocity versus time. But the shape of the graph, the first one is a straight line passing through the origin. The second one is a curve. It curves upward like this, curve upwards. Okay. The third one consists of two parts. At first, it is a straight line with slope. The second part of the journey It is a straight line, but a horizontal line. Okay. Now, what does this graph shows us? What does the graph shows us? Okay. What does the graph shows us? A straight line, a curve, and like that, two parts.
Uh, Okay.
The first one, let me say, okay, let's say this one. Now, along the straight line here, let's say I take this point, okay, and I take this point, okay. So I have
Sorry.
2 points here, okay, 2 points here. From this point to the second point, the velocity is actually increasing. So when the
Okay.
velocity is increasing, you can extend it to another point, probably over here. Okay, we see that the velocity is actually increasing. And because it is a straight line, it is increasing at a fixed rate. It is increasing at a fixed rate.
Fixed rate.
So we say that the velocity is increasing at a constant rate. So velocity constant rate, what is the acceleration then? If the velocity is constant, what is the acceleration then? The velocity is increasing at a constant rate. What is the acceleration?
Acceleration.
Okay. Now, the second case, we see that in this case, okay, we look at different points along the curve here. We look at different points along the curve here. From this point to this point. We see that the velocity is also increasing, but the rate at which the velocity is increasing is different. It is not
Okay.
like a straight line. In a straight line, the rate of increase is constant. Now, how do I know it is constant? Right? Wait, let me see this one first. Okay. Now, in order to know whether it is constant or it is not constant, I draw a tangent to this point here. I draw a tangent, okay, at this point. And I also draw a tangent at this point.
Okay.
Okay, right. Now these two lines, what is the slope of these two lines? The slope of the point, the line at the bottom here, and the slope of the line at the top. Not so clear. Maybe I make it thicker and see. Ah, yes. This one clearer. Okay, let's say I delete this point. Okay, right. So this is okay. So you see that at this point here, the slope is less. At this point here, at a higher point, the slope
Okay.
is more. So the we say that the rate of increase in velocity is here is very low. The rate of increase in velocity here is higher because it is steeper. The slope is bigger. Okay or not?
Right.
Right.
Yep.
Now in the first case, the slope along this line, all the points along this line, they are the same. So we say the rate of increase is fixed or constant. Okay or not?
Yeah. Yeah. Okay.
Okay, so we are looking at the slope there, the slope of the velocity versus time graph. By saying that the velocity increase at a constant rate, what does that mean? What does that mean? Velocity is at a constant rate. What about the acceleration? What about the acceleration? Is it increasing or the acceleration is constant or the acceleration is zero?
If it's in Mm.
The first one, the rate of increase of velocity is constant.
Constant.
Okay, so if the rate of increase is constant, when you transfer it to acceleration versus time, acceleration versus time, acceleration versus time, so which of these three acceleration versus time graph describe the first one, the first where the
E.
E is E, because rate of
You
increase of
say
velocity means acceleration. If
mm-hmm.
the rate of increase of velocity is constant, it means that the acceleration is constant. And if you
Yep.
look at the acceleration graph, the acceleration is fixed all the time. All the time. It's a horizontal line. So it is E. Now, if you look at the second graph here, the the rate of increase of velocity, the rate of velocity is increasing from a small value to a bigger value here. So what about the acceleration? Which of these three at the
D.
bottom describe the acceleration of this graph B here?
Donkey.
The answer is donkey. Donkey because you look at the acceleration, it is going up, up, up all the time. So it means that the
Yep.
acceleration is increasing and it matches with the gradient of the slope. Okay, the gradient or the slope of this tangent here increasing all the time. So the acceleration is increasing, right?
Mm-hmm.
Okay. Now, in the last case here, the last case here, the velocity versus time graph is a straight line like this. It is not a curve. So what can you say about the acceleration in this part, the first part of the journey? Acceleration is constant or increasing?
Think acceleration is increasing, but then at a certain point it becomes constant.
The velocity is increasing and at a certain point the velocity is constant. Correct.
Yeah.
The velocity is increasing until a certain point the velocity become constant. How about the acceleration? How about the acceleration? When the velocity is increasing
Okay.
at a fixed rate, it means that the acceleration is constant. Fixed
Mm-hmm.
rate means acceleration is the rate. So if the rate is fixed, that means the acceleration is fixed, it is constant. Now, for the second part of the journey, the velocity is constant. If the velocity is constant, it means that there is no acceleration. So the
Yep.
acceleration is zero at the bottom, at exactly on the t-axis here. Any question?
No, no, no.
No. No. No, then you look at these questions here. Ayo, wait, I must change back to the clear the drawing, then I change back here. Okay, now